LangGraph or PydanticAI? Ring any bells? Maybe you've already dabbled with them, or maybe you're just getting started and trying to figure out where to begin. Either way, you are in the right place. Today we are breaking down LangGraph and PydanticAI to uncover their superpowers and help you decide which one is the ultimate fit for your next project. Let's go. So what I have in front of you is a graph. And I'm not sure if you've seen my stream on Pydantic before. I'll be building the same use case as Pydantic. I've just made it like a bit better to show off some of LangGraph's capability. It's hard to do that in Pydantic. But yeah, we have a simple task management app. And what you're seeing right now is LangGraph Studio. It's not open source. LangGraph Studio is not open source, but it's free. And I think it will always be free. But at least while it's in the beta phase, it's free. And it's really cool. Let's just look at it. So I have a simple task management agent. What it does is we can give it some prompts like give me my task, we can tell it what we finished and things like that. And it will automatically update a database, an actual database for us. So it can read the database, it can write to the database, it can take care of all that crazy stuff. The only two input it needs is a user ID. I mean, technically you could have thousands of databases, so you need to like give it the user ID. Now think of user ID coming in from your authentication system, right? So maybe you have a middleware which validates some tokens and things like that, and you get a user ID from there. So I'm assuming I already have the user ID. So I give it a user ID and I can put in a query. The query I'm gonna put in is give me my tasks. So I'm asking the agent to give me my tasks, something really simple. And we're gonna learn how to build all of this. So let's submit that. Okay, now you can see that the first step in the graph is the intent classifier. Like the first step is identifying what the user really wants to do. Does the user want to get the task? Do they want to update something? Do they want to delete something? What do they want to do? Okay, let's run this. It's gonna take a little bit of it. It might take a second or two, maybe a little bit more. And it gave us an output. It gave us an output that it identified that the intent is get tasks, which makes sense, right? Because I mean, we want to get all our tasks. Next comes the task reader. Let's run that. But if you notice, task reader is like a separate graph by itself. So it's a graph with 3 steps. We have like nested graphs going on here. And like you see, it has its own start. Also, like it went ahead and read my task. So I need to buy groceries. Oh shit, I keep forgetting it. I need to walk my dog, my non-existing dog, and I need to call the plumber. Sure. But what happens next is this task is not enough for me. Just looking at task is not enough, guys. I'm a bit lazy and you cannot judge me for it. Okay, so I need to get the tasks, sure, but I want to enrich them. For 3 tasks, this enricher, you can notice it's running thrice. For every task the task manager returns, we'll have 3 enrichment tasks running, which is like an LLM prompt by itself. And all of this are being fired in parallel. So for every task, we are firing a new prompt to enrich that task. And then towards the end, we wait for all of those 3 to complete and we take the result and we give it to a formatter which can merge the results of all those tasks, merge them all in one step. And finally, once that is taken care of, the outputter kicks in, which does nothing. I mean, it just prints the output again. Very simple. We give it a query, we identify what the user really wanted to do, and we had this whole overblown system of reading tasks, which is absolutely not required. But hey, I wanted to show off some capabilities and I'm gonna do it. Let's try something else. Okay, now again, the user ID would be YourTechBud, but this time I'm gonna tell the system that I've already got my groceries. Again, if you remember, the task was buy groceries. I'm not even telling it to mark the task as done. I'm just telling it that, hey, I've already bought my groceries. Let's see what our agent does with that. So again, in comes intent classifier, and the intent classifier will kick in, give it a second, and it correctly identified that, okay, since the user is saying that he's bought the groceries, this is probably marking a task as done. The intent classifier is figuring out what exactly is the user's intent. The actual groceries in my database is not buy groceries. The user will never give the same task details again, right? Because the user is a pain in a butt. And especially if the user is me. Okay, let's not talk more about it. So we need to mark the task as done, but we need to get the real name from the database. That's where the title matcher comes in. So the title matcher will go in, let's run it, give it a second, and it figured out that the real title of the task is buy groceries. Okay, that's interesting. So how did it do that? And it also said that the title is present. So if I would have given it something stupid, it would probably just say that, hey, that's not a title. What are you saying? And finally, we go to the task updater, which will go ahead and mark the title done in the database. And that's it. And I know you guys are never going to trust me. So what I'm going to do is I'm going to open, yep, there you go. Groceries has been marked as done. We are going to be exploring a lot of code today. A lot of this is going to be really difficult to watch on the phone. I will zoom it up as much as I can, but hey, switch to a tab or a laptop. It's going to be a little easier that way. So this is what we're going to be making today. Okay, that's what we're going to be making today. Yeah. So this is precisely the graph that we're going to be making today. Another just question came in. Have you been able to build a LangGraph workflow that has cycles in the graph? This example is purely one way, or it's like more like a DAG. Yep. Prashant, that's completely right. You know, once we start going through the entire flow, you'll see that it's not that hard to make cycles in your graph. In fact, it's not that hard to get stuck in infinite cycles as well. Yeah, LangGraph does kind of make it easy to shoot yourself in the foot. LangGraph is a graph. So it's all it is that it's a bunch of nodes connected to each other. That's pretty much what it is, right? I mean, it's just a bunch of nodes. That's pretty much what it is. Start, node 1, node 2, end. What is a node? Every node is just a function with one rule, that it needs to take something called a state. Think of state as an object. It takes something called a state. It does something with the state, and then it returns a new state. As simple as that. All right. So what can you do within that node? You can call an LLM. Oh my God, no, OpenAI. This is much better. We cannot have OpenAI logos on our stream. It is not allowed. Each node is just a function. It takes in a state object, it returns a new state object, and it may call LLMs if you want to. It just cannot call OpenAI. It's just not allowed. If you use LangGraph with OpenAI, it will crash and burn. Your GPU will be set on fire. And okay, I'm not going to exaggerate. But not just that. It's just a function, right? So it means you could just talk to a database, right? You could just call any other function you want. It's just a function. You can do whatever you want with it. It's revealing the true face of AI. Just put a bunch of if-else's inside, and that's your true agent. You can do that. You can make true AI. But yeah, the point is you have a bunch of nodes, and each node takes a state, returns a state. It can do whatever it wants inside it. It doesn't necessarily have to call an LLM. You can do whatever you want with it. Really important thing to drill down. So how does it work? You can take a state and then you can return a state, and each state you return will get passed to the next node. So when the next node gets run, the state object it receives will be the state returned by the previous node. Okay, so in essence, LangGraph is a state machine. And yes, Joshua, you're absolutely right. Redux, like if you're coming from the front end world, which, hey there, what you doing here? Yes, LangGraph works like a state machine, very similar to Redux. In fact, LangGraph also has a TypeScript, and I have a project in my GitHub repo on LangGraph 101 using TypeScript. So if you want, you can see pretty much the same demo, but in TypeScript. How does it usually work? You'll start with something in the state object, like what we did. We started with the user ID. The LLM can use that initial request, the user ID, the initial query, and I don't know, add something with it. In our case, the LLM was deciding that, hey, I want to call a tool or something like that. It doesn't matter. It could do anything it wants with it, which goes to the next node. The next node could be like, hey, a tool needs to be called, and all you need to do is, okay, based on my state, I'm going to call a tool, get the tool's response, and then finally end the graph with the final response from the system. LangGraph is nothing but a bunch of nodes connected by edges. Each node is a function. So each function will run in sequence. Just think of it that way. Each function runs in a sequence. Each function takes a state object, returns a state object. The state object returned will get passed to the next node. So each node is essentially modifying a common state object, and the state object which gets returned towards the end of the graph will have your final answer. The point is you're just taking one state and you're constantly updating it. For me, every LangGraph node is like an agent. I mean, it could be an agent, but like I said, LangGraph doesn't force that. So node may not be an agent. Like I said, a node could just be a function call. It could be anything, but it may be an agent. However, the entire graph as a whole is definitely an agent. So if we go by LangGraph terms, a node could be anything. A node could be an agent. It could just be a function. It doesn't really matter. But the functionality it's trying to achieve as a graph, that's definitely an agent, right? So there'll be some LLM inside there somewhere. Cool. So what I have here, and I've already put the link to this GitHub repo for you guys, so you guys should be able to see it right away. Okay. So this is how LangGraph looks. Remember, we have a state object, right? So a state object is nothing but a class. So here I have a list of messages. That's pretty much all this is. What messages? These are your OpenAI messages. And this is something we are annotating it with a reducer. We'll get to that later. Now, like I said, a graph is nothing but like nodes, right? What's happening here is this is my first node. Like I said, it will take a state object, right? And this one, we're calling our model. And again, I've already set up my environment variables. So I usually use my own OpenAI server. so I don't use OpenAI directly. All you need to do is set some environment variables and some keys. I put this example in, so you just have to like copy it and you'll be good. So whenever I say small, that's essentially Llama 3.1 8 billion. Whenever I say medium, that is Quen 32 billion. And don't worry, I'm very close to finishing the first draft of my model gateway, so I'll be able to make my models available to you guys once the server is up, okay? So it's very close. Do join my Discord if you want access to the same models I use. It's gonna be a lot of fun. Okay, so we have a first node. It takes in a state object. We're just making a simple LLM call. If you use LangChain, this is LangChain. This is LangChain. LangGraph has no opinion on how you talk to the LLM. That's an important point to remember. So here, I'm just using LangChain, straight up. Easy peasy, okay? So once I've done that, I have to create my graph, right? So I create my graph with the state. I add my node, so I'm adding my first node in there. Okay, so we have a graph. We're adding our node to the graph. And then we start adding edges. We always start with the start node and we end with the end node, right? So we are saying, hey, start and then go to the first node, and then first node will go to the end node. But again, because these are just edges, you can connect the edges however you want, right? You can connect it from one node to another node, and the node B would go to node C, and node C could go back to node A. So you can have loops. You can just connect edges whichever way you want, okay? Just be careful of cycles. There are ways to deal with cycles. We won't really get into it. You can go through the docs, but just be aware of cycles. But yeah, this is how you make a simple graph with just one node. Start, our node. Then from our node to end, we simply compile. And then in our main function, all we are doing is like creating that graph, like basically calling this, getting our input query, using the query the user provided as my initial state. So my initial state of messages, it's gonna have just one single message. And this is, remember, I'm using LangChain. So I'm using human message. And I've put my query right in here. And if you remember, my state, that's what the first node uses. What the first node is essentially doing is it's gonna take that system message. It's gonna append that system message with whatever we got in our state. So our query, which the user passed, comes here. So this is like a consolidated list of messages. And then you just invoke it. This is how you run inference with using LangChain. But if you notice, I'm just returning the array. So I'm just returning the result returned by LangChain here. Now this is where this add messages comes in. Now this is something interesting because LangGraph is a state machine, like I mentioned, right? So whatever you return here, you don't have to return the entire state object again. You can partially return things. And what LangGraph will try to do is whatever you return here, it will try to merge it in here. But because messages is a list, we have to tell it how the merging will happen. Will it be a replace? Like, do we take this array and replace the original array? Or do we want to add the contents, whatever we return in this array, and concat it with the original array? So this add messages does precisely that. It's a reducer, which what it will do is whatever's returned will concat it to message. Like again, if you've used something like Redux or any kind of state machine or any kind of reducers in general, it's just a mechanism to, return one message and add it to the list. So if you had like a long list of messages, you don't have to return every message again and again, just return the last message and will automatically get added to this list. You don't have to return the entire list again and again. Is the state a custom class? Yeah, it is a custom class. It's just a class. Okay, let's run this really quick. I mean, we can just give it a query, give me my tasks, and if we run this, I mean, it's not going to be able to answer us because our model doesn't have access to the database right now. And I shouldn't run my code here. I should run it on a separate terminal. Okay, that's fine. Cool. Let's move on. So again, just to recap, this was a simple graph. Let's go to the next graph. Let's add the ability for our code to call tools and to actually interact with the database. For that, we first need to define a tool. And again, I'm using LangChain for all of this. So if you've used LangChain, you know exactly what I'm doing. So we have a state, but again, remember, we need to know the user ID. We don't want to get everybody's task. We want to get a user's task. So I create a state object, but I'm putting my user ID within that state object. And because it's going to be inside the state object, every node will be able to access it. And then I made a tool. This is how you make a tool in LangChain. You just add the add tool decorator. Like this function is just taking a user ID. It's calling my database function. So this function actually talks to my database, which is not just a JSON file. It's not a JSON file. It's actually a database, guys. Don't ignore the code. Ignore the code. It's actually a database. It's actually a database. So this is our tool, right? It takes a user ID and it just reads the task, right? And I'm making an array of those tools. But remember, we cannot, this function is not taking a state object, right? In LangGraph, every node needs to take a state object. So LangGraph gives us a handy utility, makes that function for us. Basically, took that function and created a node out of it. It took the function and created a node out of it. But this will only work if you're using this message. You'll never use this in production because you almost never have just a messages array. But think of it this way. If you're using the list of messages the way LangChain does things, then you can use this tool node so that you can just, you don't have to make the agent yourself. Cool. And now this time I have an agent. And because this is just LangChain, I can bind all my tools with it. Just running this one small thing will make sure that my model can now call the tools. Power of LangChain. Thank you so much, LangChain. I appreciate it. I made my system message. Because this is just a function, I can create my system message dynamic, and I'm shoving my user ID inside that system message. And then again, I'm making that list of messages like we did earlier, and we're just invoking the model. Again, remember, LangChain doesn't call the tool directly. It will just return a message which says, hey, call a tool. This tool node will look at the last message and be like, oh, the last message is calling a tool. I can call a tool. I'll go ahead and call a tool. So we have two nodes in our graph. So it starts with an agent. Then the agent goes to the executor. The executor is nothing but a tool node. So start, agent, executor is just the tool node, and then it ends. And if we run this, oh wait, I'm not supposed to run it here. So give me my task. There you go. The agent goes ahead. It does nothing essentially. And then the executor goes ahead and it actually gets me all my tasks. My buy groceries is already true here. Who cares? I think there's a question. So the state is basically a data object in this case. Exactly that. Is a data object which gets passed around through nodes. In object-oriented terms, yeah, it's just an object which gets passed around through nodes. So every node is taking that state and returning a new state, right? That return state will go inside the executor. That's essentially what's happening. Getting a little bit into Python. Getting into Python, this is a type dictionary, which means I can address the state as if I would address a dictionary, but it's typed. Normally, you would do something like state.userid, right? But this is a type dictionary. So instead of that, you'll do that. Something like this. So it's a type dictionary. Why is it a types dictionary? Because remember, you are returning dictionaries over here. You're not returning the entire state object. So you're returning partial state objects. So these are like dictionaries. LangGraph under the hood will be merging these partial dictionaries with your global state. See, I'm not returning the user ID, but if I would have done this, change everything till this, and let's say I make it whatever, we will override the original user ID which we passed away. So the original user ID we passed in the state would get overridden if we passed it. But since we are not passing it, it doesn't get changed. That's pretty much it. Very straightforward, right? We're using LangChain. Everybody likes LangChain, but I don't like something about it. Okay, I don't like one thing about this. You know what? Let me show it up front. What do I not like about this? We are exposing the user's user ID to our model. Now, in my case, I self-host my model, so it's fine. But maybe in production, that might not be the best idea because you might have some emails in there. You could have a lot of sensitive information and you do not want to push that to the model. Okay, this is one thing I don't really like about LangChain. I mean, sure, I could have made my custom class and make my custom tool and make sure that the user is like a member variable inside the class instead of using the tool decorator, but that's so much hard work. I can't do all of that crazy stuff. In LangChain, there is no way for me to do dependency injection, or there's no way for me to provide this user ID from outside the parameters. I like LangChain just about as much as you like Python. I am fussing about a stupid problem, but hey, I'm a fussy kid, okay? I had a troubled childhood. You know, there's another agentic tool which kind of fixes that problem for me. Guess where we are going with this, guys? Guess where we are going with this? Pydantic. Yay! All right, cool. Let's talk about Pydantic. So this is Pydantic code. In Pydantic, what you can do is essentially you make agents. Right? Pydantic has a concept of agents. Again, if you want to know more about Pydantic, like in depth, I have a dedicated video on just Pydantic. Go check it out. I think it's really good. I think we did a good job. Chat was like crazy in that video. I love chat. Chat, you guys are awesome. Yeah, so this is how you make a Pydantic agent. It's just an agent. You hook up a model to it. So this time you can see I'm giving it a slightly bigger model. This is a 32 billion parameter model. You could have given it a smaller model. I think that would have worked as well. Not a big deal. But you can give it a system prompt as well. You could have made it dynamic if you want to. So I could have injected user ID as well if I wanted to, but I don't want to do that. I don't want to give my user ID to the model. That's not good. So what Pydantic lets me do, one of the things it lets me do is, it lets me create a dependency class. So essentially I make a class. This is just a class. Okay, it's just a Python class, nothing fancy. It's just a Python class, and I can pass that Python class as this dependency thing. When I register my tool, this is how you register tools in Pydantic. It's just a function and you annotate it with this agent.tool. So I'm taking the agent, which is just this, and .tool. And then I think this is what they call a decorator. I have no idea. Python is. So this is my tool. And what Pydantic lets me do is it gives me a parameter called context. So usually if I wanted my own custom parameters in my tool, I could have just added it right here, right? I could have added all my parameters right here if I wanted to. I can do that. However, Pydantic will always give me this first parameter called a context object, right? And this context object will contain this dependency. Remember I said that, okay, this agent has a dependency on this class, technically an object which, follows this class. So whenever you run this agent, you will have to provide that dependency. Okay, so I'm running the agent here. I'm taking a Pydantic agent. I'm saying, hey, I want to run that agent, whatever. And I have to give it that dependency. And that dependency is the same class we just spoke about. And I have to give it the user ID. But the user ID can be accessed through the context object. All I can do now is say context.dependency.user ID. This way, the user ID never touches my model. It only stays within my application. And since this application is running in memory, which is cool, right? You're not exposing any secrets. You're not exposing anything. You're not accidentally taking a .env file and sharing it on stream in front of everybody. You're not doing any of that crap. Oh shit. I just exposed my friggin' keys. I do that every single time. So yeah, this is so much cleaner, right? Pydantic is so much cleaner. I really like this. I really love dependency injection in Pydantic. I know a lot of people have mixed feelings about it, but I kind of like it. And you know what? You do you, I'll do me. And the funny part about dependencies is that you could even pass a database driver in here. So if your agent's tool needed to talk to a database, you could technically pass a database driver in the dependencies and access it here. So you could have done DB, you could have passed like a DB, and you could have done like a DB.read tasks as well if you want. You can do whatever you want. You can pass whatever you want. And yes, Prashant, thanks for mentioning this. This data class is amazing feature. I think it's Python native. All it does is it lets me create this Python thing without having to define that init constructor and all that crazy stuff. It's a data class. I mean, it's a concept in a lot of languages these days. It's essentially taking a class and letting me define it like a constructor, almost like it has a constructor, but I did not have to define a constructor. I know it does more than that, but my tiny brain, which doesn't understand Python at all, understands it at this. I don't have to make a constructor. And now I can just take a normal LangGraph node, take the query out of that messages array. Remember, our state object is exactly the same. No changes there. We still have our messages. We still have the user ID. Again, the user ID is in the state. It's not going to an LLM. And what I can do is from the state, I can extract the user's query and I can run my Pydantic agent within a LangGraph node, pass it the query and formulate a dependency again using the state. So the state object of LangGraph has the original user ID because that's how it started, how the graph's execution started. I can take the important things I want from the state, like I'm taking the query out and I'm taking the user ID out, and I can just run Pydantic and I'll get the response. How clean is that? And because Pydantic automatically calls the tool for me, I don't need 2 nodes anymore. Like in LangChain, you have to do 2 nodes, right? Because LangChain doesn't call the tool, so you need another node to actually call the tool. It's crazy. You don't need to do any of that crap. Pydantic takes care of it. Pydantic is a better abstraction than LangChain. Or let me rephrase that. PydanticAI has a more feature-rich abstraction than LangChain. And this is how you don't really have to make a choice. Guys, we don't really have to make a choice between LangGraph and Pydantic. We can use them both together. That's what I'm really doing here. I'm making a LangGraph graph. I'm plucking the important things I want from the state and I'm just calling a Pydantic agent. You can do that. You can absolutely do that. LangGraph specializes in orchestration, rather in agent orchestration. LangGraph comes with the concept that, hey, LLMs are not smart enough to figure out or solve problems completely by itself. A developer needs to form a workflow using LLM. So of course, there will be some LLM steps. The workflow is not completely deterministic, but the workflow is, so it's influenced by LLMs. It's indeterministic by nature, but it's been crafted by a developer. And this is how I craft it, by forming edges between my nodes. LangGraph lets me do that. So it's a workflow orchestration tool. That's the concept it's drilling down. It has no opinion on how you interact with the model. It leaves that up to you. Pydantic, on the other hand, has opinions on how you interact with the model. What's the API to use when you're talking to a model? And its API is this agent class, essentially. I know Pydantic is going to get into workflows as well soon. I'm sure it will. Why wouldn't they? They'll try to each agentic framework will have some overlapping, right? I mean, it's always going to be that way. But as of today, it really shines in interacting with a model. It does have some layers on top. Like for example, it has this dependency injection. It has this tool calling. And in fact, it can technically keep calling tools one after the other till there's a conclusion. I mean, it can be really good, but it can be really annoying as well. But the point is, it has a strong opinion on how you interact with an agent. Let's do something more. Actually, let me address a concern people might have. Like Pydantic, so far what we saw, Pydantic seems to be solving every problem we have. Technically speaking, it seems to be pretty cool. Okay. So do we really need LangGraph? I mean, is Pydantic enough? Or is orchestration really that important? Or what's the beauty of orchestration? I want to do something additional. Oh, you know what? We're going to ditch the PPT. We are going to go and open my favorite tool, Excalibur. So we're going to start and we're going to end. Okay, cool. This is what we're going to make now. Let's be quick. So what we want to do is we want to get the task. So all my AI stuff is going to be in red. So we want to get the task retriever. I could have a bunch of tasks, right? For each task that is pending, I want to enrich the task. And I mean, there could be 100 different tasks. I'm not going to make every single task, okay? I'm not going to do all that hard work. That's what I want to do. And basically, when all of the enrichment is done, I want to combine it all together into a single task. So I want to format it. We want to retrieve all our tasks. We want to enrich our tasks, right? We want to add some more context to the task. This is a naive, fabricated example, but I'm sure you can think of, I mean, you get what I'm trying to do here, right? We're getting a list of items, and for each item, I want to do some processing. So I want to do that. And then I want to take all the results which I got from here, plug it into the formatter, which I again spelled wrong. God, thank God my mom doesn't watch these streams. Otherwise, she would be pissed. She would be pissed. So this is what we want to build. However, if you're paying attention, if you're using Pydantic, your instinct would be to take the array of tasks we get from this agent, loop over it, and for each task, we run the enrichment. So this enrichment is basically running in a for loop. But that's not what we want to do. We want to run them in parallel. Those are independent of each other. We want to run them in parallel. But if we run it in parallel, we'll have to have some kind of a mechanism to wait for each one of them to be completed before we run this. Because this cannot run till all of them are done. So the moment you start adding concurrency into the picture, things get complicated. Shameless plug, this little guy, king of concurrency. Like if we were using this, we would have to never worry about all of this crazy stuff. You guys understand the problem? We're getting a list of tasks. We want to enrich each and every task. So it's like another AI step. We want to do it in parallel. We want to do it concurrently. We want to wait for all of them to be done together and then run the final thing. Implementing this in Pydantic using async IO, you will have to get into the depths of async IO, and you'll have to start, then you'll have to wait for all the coroutines to be done. It's just, I mean, what are we doing at that point, right? So Pydantic has no opinions on how you do that as of today. Okay, I hope Samuel never watches this because he'll be wait, I have workflows now. But no, you don't. At least not yet. Let's see how LangGraph can make this easier. So let's go back to our code. So let me open up cursor. And this time, my state is going to look something like this. So I still have my user ID. Then I'll have the user's query. I'm ditching that messages array of LangChain. We don't need that crap. There are very few scenarios where I actually need it, only when my agents are conversational. But mostly you're not going to use it. But okay, it doesn't matter. So you're getting the query. This is the original user's query. Then you get the list of tasks, all the lists of tasks which are left. And then you get a list of enriched tasks. So instead of just taking a task, now we're taking a list of enriched tasks. And again, remember, because multiple nodes are going to run concurrently, we need to reduce them because everyone will be like, hey, I got an enriched task. So LangGraph will have to aggregate all of that together. And because it's a reducer, because it's a state machine and it uses a reducer, we can just use this. So essentially what we can do is for every task we receive, we're just going to concat it. So LangGraph is going to be like, okay, all the nodes, you give me your individual task. I'll maintain that array. I will concat it together. And the final output will be stored here. These are my state objects. Pretty straightforward, right? If you think about the enrichment one, if you think about this guy doesn't need to use the entire state. All this guy cares about is using a task object. It just needs a task, right? It doesn't need an array of tasks. It just needs a task. The state we use for this will be different than the state we use for this. So this will have all the state. This will have all the state. But when we fork or when we branch out into these individual tasks, we just want to give it a particular task and nothing more. So I have a separate state object just for that. It's just a task and nothing else. So let's start with the task manager. Again, I have a Pydantic agent. So I've already hooked up all the tools. You guys don't need to see it. It's the same thing we already saw. So I'm taking the query from the state. I'm passing it in my dependencies. It's gonna give me a bunch of tasks in YAML. So I'm just gonna format it all. I'm just gonna convert it into a dictionary, rather an array of dictionary. And then I'm just extracting all the titles. This is how my array of tasks looks. Okay. This is Postgres. This is not a JSON file. It's Postgres. So I just want the titles. I don't want this is done or whatever. We just care about the array of string. And then I'm just printing that array of tasks. And then the task manager is only returning the task array. So we are just populating this key over here. Then I have an enricher. Now remember, enricher only cares about a particular task, right? A particular task. So its state object is just going to take one task. And here I don't really need Pydantic. I think Pydantic would be an overkill for this. I'm just going to use LangChain. Or you can use L. I don't know. You can use the OpenAI SDK for who cares? Use whatever you want. So I'm just going to use LangChain here, and I'm using a small model. An 8 billion parameter model is okay. My system message, I define my array of messages. In fact, even my human message is crafted. Here's the task, right? And then finally, I invoke my model. Whatever results I get, I'm returning it in the enriched task. So even though we got the state object of the task enricher, which is just a task, we're returning the state object for the overall, because what this returns will be merged into the bigger state, or the state which was on top. I hope that makes sense. I know it's a little different. It's a slightly weird way to think about things, especially if you don't work in state machines. But trust me, this is really good because you're delegating a lot of the work to your underlying engine. And then finally, we have a task formatter, which again takes the overall state. The formatter doesn't have to worry about whether all the enrichment is done or not. It can assume all the enrichment is done. So I'm just assuming that my enrichment is already done. I'm preparing that into a string, firing again using LangChain, making my list of messages, firing the query, and returning the output. As simple as that. And here I've added all my nodes. So my task manager goes in, my enricher goes in, it's just another node, my formatter goes in. This is where things get interesting. It starts with the task manager. Whenever we are proceeding from the task manager to the enricher, we are not going to just add an edge, because this is like a dynamic edge. Think about it like a dynamic edge, right? Because like I mentioned just a little while ago, there could be multiple tasks. So there could be multiple enrichers. It's not just one edge, it's multiple edge. So it's dynamic. Whenever you want to do dynamic edges or conditionals, you use this function where you say add conditional edges. So essentially you're saying, hey, from task manager, instead of specifying a node directly, you're giving it a function. And what am I doing in that function? I'm returning an array of the send object. The send object is LangGraph specific. Essentially what I'm saying is send a message to this node with this state. This is how the state was getting mapped. We're taking this main state. We're going to loop over all the tasks in that main state. And for each task, we're going to send a message to this particular node with this state object. If there were 10 tasks, we would return an array of 10. Sends. Edges would be created dynamically for us. Essentially, like I said, you have a dynamic edge, and you're basically sending a message to this task enricher once for every task you have. Eventually, then you add an edge from the task enricher back to formatter. This is enough of an instruction to LangGraph, or this is enough for LangGraph to understand that, okay, you know what? Even if there are like 10 different task enrichers running simultaneously, I'll wait for all of them to finish, and only once all of them are finished, I'll run this. This is all you need. Like, this is how easy it is. Like, if you think about how easy it is to architect all of this, it's really easy. I mean, I cannot emphasize how amazing this is. Again, if you would have to do all this from scratch, it would be a lot more work. And it's so easy to shoot yourself in the foot. Having just one edge which says that, okay, from task enricher to formatter, and it will automatically make sure that, the task enricher completes all of its stuff before going into the task formatter. That's crazy, man. That's crazy. And because we're going into the task formatter, whatever the task enricher returns, so whatever you return from the task enricher, it will have to be the state which follows that. So because task formatter comes after enricher, the state you return here will have to follow the state this guy is expecting. So technically, I could have an enricher, and that could have gone to another site. It could have done some more agentic work. It could have done some more branching, joining, whatever. And eventually, it could all go to the task format. It doesn't matter. You can add as many edges. So this task enricher could go to another side edge, and that side edge could come to the task format. I mean, you can go as crazy as you want. All you need to do is draw some edges. It's so cool. Technically, LangGraph also creates those graphs for you. So it would create this nice little graph for me. The problem is I'm using WSL. So the IPython doesn't really work for WSL. Moreover, you notice there's an error. There's an error here. It's actually not an error. I don't know why this is happening. Again, stupid Python. I'm going to take every opportunity I get to diss on Python, because that's what Python deserves. There's just one more thing I want to show you. The final step is what I showed you in the demo, right? The original demo, which is essentially this graph. So I'm not going to draw it again. I am lazy. So whatever you saw so far, the task manager, the task enricher, and the task formatter, this was this graph. It's just the read aspect of the graph. So this is how you do reads. And now let's say we wanted to put that mutation thing as well. We want the user to be able to say that, hey, I finished something, and the agent dynamically figures out, okay, this is the task the user is talking about, and mark it as done. How do you do that? There are multiple ways to do it. I'm just going to tell you how I did did it. So essentially what I did was before the task retriever, I added another node. And what I did was I added an agent which can classify intents. So an intent classifier. This is doing is basically analyzing the user's question and trying to understand whether the user is trying to read, is trying to add a new task, or is trying to mark a new task as done. Why did I do it? Because I use open source models, and open source models can be stupid. Please don't tell Llama 3.1 that I called it stupid, but it can be a little stupid sometimes, okay? So usually what I do is I'd like to break these tasks into smaller tasks, specializing in one thing, right? So every task is a node for me. So I basically go to a intent classifier, and if the intent was read, we can essentially just use this graph as is. Now this is a cool part, okay guys, pay attention here. I already have a graph, and like I said, in LangGraph, graphs are agents, right? Technically, I just want to use that agent again. LangGraph lets me do that beautifully, because one of my nodes could just be a graph. So because I already have an agent which does retrieval of tasks really well, I can simply reuse it. So we have composable agents here. That is insane. I love this. Again, if you come from the front-end world and you use React components, like you can use one React component in another React component, right? It's composable. And I think that's how agents should be. Like I had given a talk back in 24 in July or something, where I was like, one of my criteria for something to be agents is composability. That's how important I think composability is. I have an agent which does one thing really good. I want the ability to use it in a bigger agent or in a bigger workflow without having to worry about re-implementing it, because this agent is kind of giving me some guarantees. Basically, it's going to make sure that, okay, I'm always going to get my task the way I want. I can test it in isolation. I can make sure it always works, and I can just keep reusing it. In an indeterministic app or non-deterministic application, having some sense of security that, okay, my agent is tested to do some things really well and I can trust it, that's a relief. I don't want to have distrust in every node. And if I club some pieces of logic together in a graph, test it out, make it reusable, and then just reuse it across my code base, dude, that's a big W in my books. That's a big W in my books. Okay, cool. So we have an intent classifier. If the intent was marking a task as done, we'll add another node. This node is essentially going to query the database. So what it's going to do is, if the intent was to mark as done, we want to get all the tasks which are pending for that user from the database and kind of compare. These are the tasks in the database. This is what the user says that he wants to mark as done. Can you match it for me? Can you find a matching one? If you don't find a match, great, it's fine. You know what? It's okay. But if you find a match, tell me what the match is. The title matcher will make sure that I always get a title which is definitely there in the database. Which means that when I create a task modifier agent, this agent doesn't have to worry about figuring the right task name. This guy has already done it for it. Once we have modified things, we can mark it as done. So we basically need to call a database here. We need to call a database here. It's not a tool call. Again, title matcher is not doing a tool call. It's just reading all the tasks up front. It's just plugging that in the system prompt, pretty much. So intent classifier is an LLM router. It's an LLM based router, and based on the intent, it's going to do some routing. And then if it was a read, then we're going to use the graph which we already created. If it was a mark task as done, then we're going to get into a title matcher, which is going to call a database under the hood, figure out that, okay, which based on the user's query and the task I've received, which is the right match, identify that, and then pass to the task modifier, so that the task modifier can modify it. Does the intent classifier route either to the read node or the title matcher node? Yes. It's a router, so it is making a decision and it's routing it. How about Pydantic? Is that for prototyping as well? It all depends on how do you build backends, okay? So, Mr. Vision, if your backend is primarily in TypeScript, let's say use Next.js. A lot of your backend would be done in Next.js, right? Most likely. Wouldn't it make a lot of sense if all your code could be in just one code base? Isn't that easier? Or would it be easier to maintain two different code bases, one for Python and one for Next.js? So it's all about reducing tech debt. Are you going to be more comfortable in using your primary language, or are you going to be more comfortable in using specialized languages for specialized use cases? By the way, using specialized language for specialized use cases is not a bad idea. That's literally what microservices are. Like every team can choose their own language and they can specialize in what they use. They can use the tools which are perfect for that task. So it's not a bad thing. It's just, for me, for your TechBud, Go is the primary language. I use Go a lot. I love Go. All my backend happens to be in Go, and I'm really good with it. However, if you get into the RAG side of things, like the data engineering part, I probably wouldn't do that in Go. I mean, I still have to encounter some use cases where Go lets me down, but might not want to implement a lot of the things which the LangChain indexers or text splitters or the Llama index parsers have already implemented, right? So for those things, you might want to use Python, just because re-implementing all of that in Go would be a gigantic pain. But again, Cursor is pretty good. I've been using Cursor for ages. Dude, it's so good that I think re-implementing stuff, as long as you know that you'll have to maintain it. I mean, I'm okay with it, dude. I'm okay with it. So it all depends on you, right? So Pydantic is really good. If you want to use Python and you're going to stick with Python as a language, Pydantic is solid, but it's not crazy enough that you cannot re-implement it within a few days. I mean, you don't need all the features Pydantic has to offer. You just need maybe dependency injection, or maybe you just need type safety. That's already there in Go. That's already there in TypeScript. Like in TypeScript, you can use Zod. I mean, I can just do that in Go out of the box. Doing it in Python is a big thing because Python doesn't have a native support to do those things. I mean, you have Pydantic, but sure. I mean, you can technically make PydanticAI yourself using Pydantic. Let's get back to the main thing. So this is what we want to implement, right? It's actually not that hard. So this is my overall state. I just have my query. I have my intent because the intent classifier needs to do that. I have a title matcher. And we also want to know if the title is present or not, right? Because the user could just put something absolutely stupid. And then finally, you have an output. Sure. This will store the final output. So my intent classifier, I already have Pydantic agents for each one of them. I made all of this in my Pydantic stream. So you can check out the video on PydanticAI. You can just check it out. You'll see how I made all of these. But again, it's not doing something fancy. This is one of the cool Pydantic features I really like, where Pydantic can give structured responses. I'm making a Pydantic agent. I'm saying that, hey, identify the task from these 3 options and give me the answer back as a class. So the answer will be given back as a class. So essentially, if the model decides an action which was not in my list, I can retry. I can ask the model to retry and say that, hey, you know what, model? Please choose from these options. You chose an option which I don't really understand. So Pydantic is not only doing a schema validation, it's also doing a data validation. That's one of the Pydantic features I love. So dependency injection and structured responses. I love Pydantic. Like Pydantic has done a really good job. Like I really love the way it's structured, because one file with that particular agent, and all I need to do is import the agent and do run sync. And this result, it's typed. It's all typed, and it's safe because it's actually doing a validation. So yeah, I love Pydantic, right? Intent classifier, it classifies the intent and it gives me the action, and I'm storing that in my state. So taking stuff from Pydantic, putting it in my state. Then I have the title matcher. Again, the title matcher is yet another Pydantic agent. This could have been a LangChain agent, but again, it's a result type. Whenever I want structured responses, I just tend to use Pydantic now. I just like it. I mean, this is what I want, title and is title present. Remember I said I'm going to read the task from the database, but it's not like a tool call. So what I'm doing is I'm generating the system prompt dynamically, right? You can do that in Pydantic. You can generate dynamic system prompts. And again, I get my dependencies. So I get my context object. So I can use the user ID in my context object and call my database directly. Remember, this is not JSON, this is Postgres. So it reads all my tasks from the database and it will get me the titles, and I'll just shove it in my system prompt. So you're technically calling a tool, but that decision of calling the tool was not made by the model, it was made by the developer. So I'm just calling this tool or calling this as a function. It's just a function call before we even make the first call to the model, right? This is what the system prompt does. Again, some neat features Pydantic gives me. I really like it. You don't need to use Pydantic. You could have done this with L or LangChain, whatever. So that's my title matcher. So again, it's all going to be structured. So I can just do a dot title and dot is title present. By the way, LangChain has a with structured output kind of a thingy. So it can technically do structured responses as well. It's just not as good as Pydantic. So yeah, you get your structured response here. And then I'm adding it in my state in the title and is title present. And then obviously we have a task mutator. I won't get it. It's just an agent which can call some tools to read, update, and things like that. Similarly, we have something for the updater. In fact, it's the same agent. So I could have used the same node here. I just made separate nodes because it would look, technically these could have been the same node. That's pretty much it. Now, how did you construct the graph? I'm sure somebody asking that. So you add all the nodes, right? So I added the intent classifier, added the title matcher, I added the task reader. But task reader, my friends, is not a node. It's a graph. I'm literally returning the graph which we created in the previous example and using that as a node. I'm taking the graph from the previous example and using that as a node. I can just do that. I can just do that because the state objects for both of these are compatible. They're compatible. Like graph puts its output in the output field, and this has an output field. So you know what? It works. So I can literally add a graph as a node. And this is the composing point I was saying. A graph which I've built earlier, which I know works, can be used as a node in a bigger graph. And that's exactly what I've done. I've added all my stuff in here, but somebody had asked a question about routing. Is it making a decision? Is it routing? So if you remember, intent classifier, all it did was added the intent to the state. It did not really say what comes next. But again, this is where conditional edges comes handy. So I can say that, okay, I want a conditional edge from intent classifier. And if the intent was add task, forward it to this node. If the intent was mark as done, forward it to the title matcher. If the intent was get task, forward it to the task reader. And if it was a valid intent, just end the graph. So if it was an invalid intent, end the graph. I can have a node which just does structured responses, and I can have a conditional edge to use the data returned in that structured response to route it to my subsequent nodes. And again, this could be cyclic, this may not be cyclic. It honestly doesn't matter. You could return whatever node you want, right? You could return the same node, and you can have limits on how many times a node gets called. You can do all those crazy things as well. And then obviously for the title matcher as well, I have another router saying that if the title was present, only then go to the task updater, otherwise don't go to the task updater. And finally, I just have my final edges saying that whether it's task adder, whether it's task updater, or whether it's task reader, they all go to the outputter, which just prints stuff. But the output graph will look like this. And this is LangGraph Studio, guys. So does LangGraph manage conversation history across nodes? Who has access to that? I mean, any node can access overall conversation thread using its execution. Yes. Good question. The state object, that's where you put stuff. So your conversation history, if you want to store a conversation history, you would store it in the state object. And like I said, the state object gets passed to every single node. The intent classifier can access the state object, and it's adding the intent in the state object, right? The title matcher could use the same state object and access the intent which it got earlier. So here, essentially what I could do is state intent. I mean, not write to it, but read from it. Essentially, every node in that graph can access the same state. So your conversation history would go in state. That's for short conversation. That's a thread of conversation. If you want to store past conversation history, as in you want memory management across conversations, so you want multiple threads, LangGraph can do that as well. But you will have to use something called a checkpointer. I don't want to discuss that in this stream. I have spoken about checkpointer in my LangGraph video, so you can check that out. But yeah, you can technically persist states in a database as well if you want to do that. You can absolutely do that. So the router here is not LLM based. The router is LLM based, my friend. The router is LLM based, and I'm glad you asked that question. The intent classifier is an LLM, right? It's a Pydantic agent deciding what the action should be. LLM goes ahead, makes the decision that, okay, the action is this. Then the router, all the router is doing is using that state object to route it. So it seems like the router is deterministic, which it technically is, but the value of the intent in the state came from an LLM. So it's an LLM powered decision. LangGraph Studio essentially gives you it's a part of LangSmith. So it's the observability tool, which reminds me, if you're mixing different frameworks together, sorry, I'm going back. I know I use LangChain and Pydantic in the same framework. The problem is all these frameworks work with their own observability tools. So the LangChain ecosystem works with LangSmith. The Pydantic ecosystem works with Logfire. So out of the box, none of them will work, right? Because LangSmith won't be able to capture things in Pydantic, and Pydantic won't be able to capture things in LangChain. So your observability gets disjoint, and you'll have to stitch it up together, which is painful. But I would argue the observability of either these tools is not that great. I would probably do it myself anyway. The best agentic framework is the one you write. Abso-frigging-lutely, my friend. The best framework is the one you write. Take the opinions you'd love. Like if you love state machine, use that. If you don't love state machine, you love custom logic using vanilla programming language features like if else switch cases, for loops, use that. Doesn't matter. You like dependency injection Pydantic gives you, use that. If you're using Python, sure, you can embed these different frameworks or libraries into your own framework. You can go crazy with it, but just know that everything you write is technical depth, so just don't go crazy about it. Like, share, and subscribe if you found this video to be helpful. And don't forget, I am your tech bot here on YouTube and hopefully in real life.